Hello everyone. Thanks for joining my session today. My name is Sayem. I'm an analytics specialist SA at AWS. I work with customers to solve their business problem using distributed computing, and I heavily focus on real-time data analytics. Today, I will talk about building a high-performant, scalable real-time analytics solution using Apache Flink on Kinesis data analytics. So here's my agenda today. I will quickly explain the evolution of data processing in recent time. Then we'll give you an overview of the growing trend of using Apache Flink for real-time analytics. I'll talk about the feature set of Kinesis data analytics for Apache Flink. I will show you a reference architecture pattern to build a streaming analytics solution at AWS, and finally a demo of running Flink SQL on a new tool we have introduced recently called Kinesis Data Analytics Studio. So let's start with a bit of history. As you know, in human history, data processing is very old, right? The earliest example we have human storing and analyzing data was in the tally stick back in 18,000 BCE. If we fast forward the history, from 80s, we saw a rise of adoption on RDBMS for transactional data processing. And this is still the case. Eventually, we humans started using computer or of its kind a lot. We started generating lots and lots of data. Then we realized only using RDBMS is not going to help us to get all the answers we want from the massive amount of data we generate continuously. So we started looking into options. And I think this is very familiar to all of you as well. One major thing we identified is we need answer from those data in different way, in different time. Means we have a different latency expectation. And now we also expect data will tell us the fact by itself. For example, machine learning capabilities. So we have realized we have two high-level data processing patterns: transactional data processing and analytical data processing. We also realized there is no tool like Swiss Army knife can solve that problem. We need right tool for the right job. So we started building processes to run transformation on those transactional data, which famously known as ETL process. So we can send those transactional data to data warehouse to consume in an efficient way we want to consume for analytical purpose. So we solved one problem by separating transactional and analytical workload. But things are not that easy. We started seeing explosion of data, and it's not anymore just coming from our transactional databases. Every machine started talking. It's just not only the traditional IT system, but any electronics device started chatting a lot. It started sharing what's happening inside to that non-living thing. So we see lots and lots of data are generated continuously. Since the data started coming continuously, more frequently than ever, we demanded to make a sense of those data in seconds instead of waiting for hours or days with traditional batch processing. So we come up with a new concept to handle that, which we call event processing with stream processor. And as you might know, the first generation of event processing technique, famously known as the Lambda architecture, was heavily focusing on providing low latency data processing without support for result accuracy and consistency. And we kind of accepted that shortcoming for a while. The solution was, if you want faster result, okay with approximate result, you use stream processor. If you need result accuracy, periodically process those data with batch processing engine. So you write the exact result into the batch table and drop the corresponding inaccurate result from the speed table. So which means data correctness is a challenge in stream processing, right? Because at the core, if you need data correctness, you need a consistent storage. So when Apache Flink, Apache Spark appeared, it was revolutionary, providing consistency and result accuracy in real time and at massive scale. And things has started improving. Now we see more and more business are relying on stream processor as their core engine for accurate data processing at a very high throughput. So with that bit of history of data processing, let's now focus on the next generation stream data processor, Apache Flink. Since Flink was donated to open source community back in 2014, it has developed rapidly. Currently, Flink is one of the most active projects in Apache Software Foundation. On GitHub, Apache Flink is one of the top Apache projects. Flink offers a different level of abstraction for developing streaming and batch application with high-level languages like SQL, Table API, core APIs with data stream, and of course, providing fully unified Table API and SQL for batch and stream processing workload. The framework supports Java, Scala, and Python as programming language. It provides processing guarantee out of the box with many inbuilt connector support to connect with external system like databases, distributed file system, etc. Also, Flink can handle large state while processing data at massive scale with its unique incremental checkpointing mechanism. So you can run Flink in container with Hadoop Yarn in a self-managed environment, let's say. As you know, running such distributed system is error prone and complex to operate as well. And that's where Kinesis data analytics for Apache Flink can help. It is the easiest way to transform and analyze streaming data in real time with Apache Flink. It is a serverless service. It processes streaming data with sub-second latency at massive scale, and you pay only for what you are using. Due to the nature of the serverless system, the service automatically scales the infrastructure up and down as required to process the incoming data. It provides high availability of your Flink application out of the box. So it means you can focus more on building the feature needed for your real-time analytics platform instead of managing such complex infrastructure. For example, doing patch management, doing operating system upgrade, Flink version upgrade, and so on. With Kinesis Data Analytics, you can do stream processing with Kinesis Data Stream, Apache Kafka running in a self-managed environment, or using Amazon Managed Streaming for Apache Kafka. You can deliver your process data to different destinations. For example, to Kinesis Data Stream, to Apache Kafka, to Amazon S3, Amazon RDS, Amazon DynamoDB, or many other built-in connector Apache Flink offers. Also with Kinesis Data Analytics Studio, which is a new feature we have released recently, you can interactively query data streams and rapidly develop stream processing application with an interactive development environment using Apache Zeppelin Notebook and Apache Flink. Now, in this architecture, I have two different data streaming storage technology. I mentioned Kinesis Data Streams and Amazon Managed Streaming for Apache Kafka. Let me quickly summarize the feature set of these two streaming storage engine, which you're going to use most frequently while using Kinesis Data Analytics for Apache Flink. Let's start with Kinesis Data Stream. Amazon Kinesis Data Stream, or KDS, is a massively scalable and durable real-time data streaming service. It is serverless. You don't need to do any storage capacity planning. The service synchronously replicates your streaming data across 3 availability zones in an AWS region. The data retention is configurable. It provides up to 365 days data retention. In terms of producer to consumer latency, you get 70 millisecond or better latency with enhanced fan out feature. And KDS has integration with many other AWS services, including CloudWatch, IAM, AWS Lambda, Kinesis Data Analytics, Amazon DynamoDB, etc. And Amazon Managed Streaming for Apache Kafka, or Amazon MSK, is fully managed service to run Apache Kafka workload. Amazon MSK makes it easy to run your Apache Kafka workload. With few clicks, you create a production-ready cluster, You can do vertical and horizontal scaling of your Kafka cluster as you need. It is fully compatible with open source Apache Kafka and can be deployed across 2 or 3 AWS availability zones. The service secures your Apache Kafka cluster by encrypting data at rest. It provides lowest TCO in the industry. Amazon MSK provides multiple levels of security of your Apache Kafka cluster, including network isolation with VPC, AWS IAM for control plane, and data plane authorization. Encryption at rest, TLS encryption in transit, also TLS-based certificate authentication and SSL screen authentication. So with that quick overview of Amazon MSK and Kinesis data stream, let's switch back to our original discussion on Kinesis data analytics. To summarize the feature set of Kinesis data analytics for Apache Flink, it is stored transient data in a state backend. It uses RocksDB state backend for that. And then asynchronously takes state snapshot in Amazon S3. It has integration with Amazon CloudWatch for monitoring and debugging logs. The service also exposes Flink dashboard in a read-only mode, so you can get detailed Flink log easily. Kinesis data analytics monitor the CPU usage of your application and elastically scale up and down your application. The service is a part of multiple AWS compliance program, including SOC, PCI, and HIPAA. And when you deploy your Flink application, it runs on a single tenant Apache Flink cluster running in high availability mode across 3 availability zones in an AWS region. Last but not the least, with Kinesis Data Analytics Studio, you can interactively query data streams and rapidly develop stream processing application powered by Apache Flink. Let's now discuss about architecture pattern on real-world use cases using Kinesis Data Analytics with Apache Flink. So in this example, imagine you want to build an modem device monitoring system to identify the performance of the modems, location tracing from where they are connected, understand the health of the device so you can take proactive action as needed, which means you are capturing this modem data in real time and send those data to a Kafka topic on Amazon MSK. You use Apache Flink on Kinesis Data Analytics to run real-time aggregation to understand whether, let's say, device performance is breaching a certain threshold within a time window that you define. Run ad hoc query on those incoming data using Kinesis Data Analytics Studio and build your Flink application. Finally, you send those processed data to another Kafka topic to generate real-time alerting using AWS Lambda and Amazon SNS. Now, let me show you a demo how you can use Kinesis Data Analytics Studio to process data from Apache Kafka. So for the demo, what I'm doing, I have a Apache Kafka cluster running on Amazon MSK, and then I will use Kinesis Data Analytics Studio for analyzing incoming data on that Kafka cluster on Amazon MSK. So I've already created the Kafka cluster on Amazon MSK. This is the Amazon MSK console as you see, and this is the cluster I'm going to use for the demo. And let's go to the Kinesis Data Analytics console, and as you see, this is the Kinesis Data Analytics console where you can deploy your Flink application writing code in let's say in Java, Python, or Scala. Right now I'm using Kinesis Data Analytics Studio for running some ad hoc query on those incoming data in Kafka topic. And creating a new studio is also easy to do. You click on the Create Studio Notebook button, and then you specify some settings, for example, like the notebook name, and especially if you're connecting with Apache Kafka cluster, you will specify some networking settings or networking configuration, going to these custom settings. So for this demo, I have already created the notebook as well. This is my notebook, my MSK notebook. Since this is running, I'm gonna click on Open in Zeppelin to start exploring the data. For that, I have two separate note in the notebook. One is as a random data generator, mocking some let's say modem information I'm ingesting to my Kafka topic, and then I'm using another node to analyze those data. So for the first one, so this is my Kafka generator. So for Kafka generator, what I'm using Kafka Python library to start, which is a client can be used to ingest data to a Kafka topic. And this is my producer code where I'm sending some random information about the modem, device information, whether the interface is up or down, some location information. So let me run this again. So as you see, it has started ingesting data to my Apache Kafka cluster, so which means I should be able to start analyzing those data. So for that, I have another node. Let me open that one and let me clear the existing output. So what I'm doing here, let me explain a bit more. I'm using Flink SQL for analyzing data from that Apache Kafka topic I'm ingesting at the moment with my random data generator, right, which is still running. And the way you create a table in Flink is kind of the same way you can think of when you create a table in a relational database, with some additional settings. For example, like you're going to specify the connector, what type of connector it is. If it is Kafka, you will specify the topic name, your broker detail, and also the data format, let's say. So I've already created the table. So it means I should be able to start reading data on that table, right? So my table name is Kafka device status. Let me run this command. This is like very common SQL statement, right? Want to see all those data available on a specific table. So let me run this on Flink. It should be able to start reading data, all those incoming data right now on this Kafka topic I'm still generating. So behind the scene, it is subbing a job in Flink cluster managed by Kinesis Data Analytics Studio. And then as you see, these are the incoming data I have on my Kafka topic at the moment, like some location information, device temperature, what is the model of the device, and so on, and whether it is connected, what is the CPU usage or the memory usage, and so on. Let me stop that and run a bit more complex query. So complex query means, let's say for example, I want to run some aggregation here where I want to see state-wise uptime information for all those modem I have. So which is a bit more complex query with a time window defined here. I'm using tumbling window for that query. So let me run that one. So while it is running, as you see in Zeppelin notebook, you can have a table view. You can also have other visualization as well, like for example bar chart, to build a kind of like ad hoc dashboard very quickly. And as you see, it has started analyzing those incoming data and populating the bar chart, where I see many devices are connected in NSW, a few of them are down in NSW as well, and these visualization will also change continuously based on the incoming data that you have. You can also change the settings, visualization type, or adding visualization in a different way, going to the settings tab. You can change those as well. Let me stop this, and I'm not going to run the next one. This is just another example that how you can run some useful query but in a very easy way. For example, like here I'm analyzing device-wise uptime, where I'm grouping by all those information using device model, right? And here is another example where you can run a bit more complex query, like we call it in Flink. It calls for example, like running pattern recognition. So this example where it is it's going to help you to find the longest period of time for which the average CPU usage of the device did not go below certain threshold within the interval that you are specifying, and the threshold I specified is 95, let's say. It takes a bit time to start aggregating or analyzing all those data. When it is doing, let me show you one more feature on Kinesis Data Analytics Studio Notebook. So let's say, for example, when you are ready, or when you decided these are the business logic that you're going to run, and after that you will deploy it as a Apache Flink application, and behind the scene Kinesis Data Analytics will run your application. So for that you can build the application here. So once your application code is ready, you click on the build application button, and then it will build your application, and then finally you will deploy that application to run it continuously on Kinesis Data Analytics. And now, as you see, it has started identifying those devices based on the query I'm running, and then this is one example where you can start now sending some alert. Maybe you're going to send those information to a different Kafka topic, and the example that I've shown in the reference architecture, where then that Kafka topic can be triggered, or Lambda trigger can be configured with that Kafka topic to send notification based on the business rule that you define there. So that's about the demo. Let me switch back to the presentation. To recap, as I mentioned earlier, data is growing exponentially. We hear from companies all the time. They are looking to extract more value from their data, but struggle to capture, store, and analyze all the data generated by today's modern and digital businesses. It is coming from new and increasingly diverse sources, and needs to be securely accessed and analyzed much faster than ever. And the best way to get timely insight and react quickly to new information you receive from your business and your application is to analyze the streaming data. Apache Flink is one of the popular open source data processing framework is used to analyze real-time streaming data, running complex analytics with low-level API, data streaming API, with high-level API like table API and SQL, with processing guarantee out of the box at massive scale, and with broader ecosystem support in the industry. Also, Kinesis Data Analytics makes it easy to run your Apache Flink application without managing a complex distributed framework like Apache Flink. It is a serverless service. It is scaled automatically to match the volume and the throughput of your incoming data, and you pay only for what you are using. Finally, to make it easier to analyze streaming data, we have introduced Amazon Kinesis Data Analytics Studio. From the Amazon Kinesis console, with a single click, you can start a Kinesis Data Analytics Studio powered by Apache Zeppelin and Apache Flink to interactively analyze data in Kinesis Data Stream and Apache Kafka. Here are some of the additional resources that will help you to learn more about big data processing. I've also shared a workshop link and also an example focused on Kinesis Data Analytics for Apache Flink, which you can try on your own AWS account. I hope it was useful. Thanks for watching.